one of the organic chemistry lessons, that is the topics haloalkanes and haloarenes. Now first of all, what are haloalkanes? The word halo, you know, as usually we are indicating for halogen. It is a prefix according to IUPAC used for halogen atoms, right? Now alkanes, you know, these are the saturated hydrocarbons. Now what are haloalkanes? Halogen substituted alkanes. If in any alkane, if one or more hydrogen atoms are replaced by halogen atoms or atoms, then such type of compounds are called as haloalkanes. Okay? So, next we are going to see about haloarenes. Now, as usually, the prefix halo indicates halogen atom. Arenes, what are arenes? Aromatic hydrocarbons, another name is arenes. So, if one or more hydrogen atoms are replaced by halogen atoms from aromatic hydrocarbons, then such type of compounds can be called as haloarenes. Okay. Okay. Now let us see classification. Okay, or the types of haloalkanes as well as arenes. Now basically the first type of classification we are going to see it based on number of halogen atoms, So, if any compound contains single halogen atom attached to it, then it is called monohalo. You can use the term monohaloalkane. Or if two halogen atoms are attached, then you can use the term dihaloalkane. Similarly, if three halogen atoms are attached, then you can say it trihalo. So like this, based on the number of halogen atoms attached to the particular alkane or to particular compound, you can classify it as monohalo derivative or monohalo compound, dihalo compound or trihalo compound, and so on. Like that, if n number of halogen atoms are attached, then you can call it as polyhalo. Poly means many halogen atoms are present in a particular compound, then it is polyhalo hydrocarbon. Then Among dihalo, we have one particular type of nomenclature or the type of ways of saying it, that is, those are again two types: Gem-dihalides and vicinal dihalides. Gem-dihalides and vicinal dihalides. So among dihalides you get this type of classification. Further classification: hydrocarbons, dihalides are again classified into gem-dihalides and vicinal dihalides. Now in detail we will see what is the difference between them. Okay. Now we will see what is meaning of gem-dihalide. Okay. Now, in gem-dihalides, if two halogen atoms are attached to the same carbon, if two halogen atoms are attached to the same carbon in any dihalide, then such type of dihalides are called as gem-dihalides. Okay. For example, CH3, CH, Cl and Cl. I am writing a compound like this: CH3, CH, Cl and Cl attached to the same carbon. So according to IUPAC, I start numbering from here. This will be the first carbon and this will be the second carbon. So you see, IUPAC nomenclature is 1,1 dichloro. 1,1 dichloro ethane is the IUPAC nomenclature of this gem-dihalide, or it is also called gem-ethane dichloride. Okay, gem-ethane dichloride. So this is one particular example where you are finding that two halogen atoms are attached to the same carbon. So this is gem-dihalides. You can also see in any aromatic or cyclic compounds. You can see here, for example, I take example cyclohexane. So I will start numbering from here. Then it will become 1,1 dibromo. 1,1 dibromo cyclohexane. 1,1 dibromo cyclohexane. So all those compounds in which two halogen atoms may be same or different, if they are present on the same carbon, then such type of halides are called as gem-dihalides. Now we will see the second type of dihalides, that is vicinal dihalides. Now what are vicinal dihalides? If two halogen atoms are attached to the adjacent adjacent carbon atoms in any compound, then such type of dihalides are called as vicinal dihalides. Example, CH2 Cl Cl. This is one example for vicinal dihalide. What is the IUPAC name of this compound? 1,2 dichloroethane. 1,2 dichloroethane. Another example, if cycloalkanes I take, then ClCl. If I write like this will be 1 and 2 positions. This will become, so first classification we have seen based on the number of halogen atoms. Now, based on the type of carbon to which the halogen atom is attached, we are doing the further classification. That is, based on the halogen atom attached to the type of carbon atom. Now we are seeing the classification. Now in this, if halogen atom is attached to sp3 hybridized carbon, then the classification is 3 types of it. That is alkyl halides, aryl halides, and benzyl, or you can say benzylic halides. Okay? If halogen atom is attached to sp3 carbon, okay, then further classification is alkyl halides, arylic halides, and benzylic halides. We will see one example here. Alkyl halides. Example, I will say ethyl chloride or methyl chloride. You can see it is CH3 CH2 Cl. You know that this carbon is sp3 hybridized. So the halogen atom is attached to sp3 hybridized carbon. So that type of halides are called alkyl halides. If in alkanes one of the hydrogen is replaced by halogen, then it will give rise to alkyl halides. Similarly, aryl halides. Now example for arylic halides. You know, aryl group means which group? CH2 C double bond CH2. This group is called as allylic group, right? This is allyl group. And if any halogen atom is attached to such type of sp3 carbon, okay, then that is called allyl halide. It is called allyl halide. The common basic example, simple example, we take simple allyl compound CH2Br. This is allylic bromide. Allyl bromide, you can say. Similarly, it may be in cyclic compounds also. The allylic position can be occurring in cyclic compounds also. For example, if you take a double bond here, this position and this position is allylic carbon. So, here if halogen atom is attached, then this will also become allylic compound. But it is in cyclic compounds. Now this is a straight chain compound. Okay? And next we have seen benzylic or benzyl halides. What does that mean? If benzene ring attached to methyl group, you know that it is toluene. And if one of the hydrogen atoms from methyl group of toluene is replaced by any other atom, then such type of group, here it is benzylic. It is benzylic group. Now, if one of the hydrogens is replaced by halogen, then it is benzylic halide. For example, I will take a benzene ring CH2Cl. Okay? So that is, this carbon is, as you know, it is sp3 hybridized. And that is attached to benzene ring on one side and chlorine atom on the other side. So this is an example of benzylic halide. So benzene ring CH2Cl. Here CH2 is sp3 carbon. Such type of halides are called benzylic halides. Now, if the halogen atom is attached to sp2 hybridized carbon, then here we come across two types of halides. Further classification, that is vinylic halides and aryl sp2 carbon. Then the halides can be classified as vinylic or vinyl halides and aryl halides. Now, as you know, CH2 CH double bond, this type of group is vinyl group. Okay, it is called vinyl group. And if an halogen is attached to such type of sp2 hybridized carbon, then such type of halides are called vinyl halides. Example, CH2 double bond CHCl. Okay, chlorine is attached to sp2 carbon. So this is an example of vinylic compound. Similarly, we have aryl halides. Now what are aryl halides? If an hydrogen is replaced from arene or aromatic hydrocarbon, that is, if hydrogen atom on the benzene ring is replaced with halogen atom, then such type of halides are called as aryl halides. Example, benzene ring attached to one chlorine atom. This is chlorobenzene. As you know, this carbon is sp2. In benzene, all the carbons are sp2 hybridized. So, halogen attached to sp2 on the benzene ring. Such a type of compounds in which the halogen atom is attached to the sp2 carbon on an aromatic hydrocarbon, then such type of compounds are called aryl halides. Example, chlorobenzene. Okay, or you can take any other examples like benzene attached to bromine, like bromobenzene or iodobenzene, and so on. So we have seen classification of haloalkanes and halides. Now let us see nomenclature. According to IUPAC, how to name any haloalkane or any haloarene. We have some common names, and you also got to know how to write the IUPAC name for haloalkanes and haloarenes. Okay. One example, one simple example we will start with. Okay, so this is the compound we have CH3, CH2, CH2, Br. As you know, the numbering must be from the halogen atom, from halogen atom side. So this name is 1-bromo propane. Okay, 1-bromo propane or bromo propane, you can call it. And as you know, you should not use any alphabet letter in this. Okay, capital alphabet. Now coming to another example, CH3, CH2, 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 Br, and let me take one more Br here. So in this case, the numbering should be from this side, because if I number from here 1, 2, 3, 4, 2 bromine atoms are falling on first carbon and second carbon. Instead, if you do from this side, so it will be 1, 2, 3, 4. It will become 3 and 4 carbon. As you know, according to least sum rule, 1 plus 2 is least, that is 3. But if you number in this way, it is 4 and 3. So 4 plus 3, it is a big number. But here 1 plus 2 is small number. So least sum rule we are following and numbering from that side. Okay. So what will the IUPAC name of this compound? Where are the bromine atoms present? First position and second position. So you take the numbers first. 1, 2. Since it is the same group, so it is 1, 2 dibromo. 1, 2 dibromo, and it is butane chain, right? So 1, 2 dibromo butane is the name of this compound. Similarly, if in example we have CH3, CH2, CH, Cl, CH2Br. Then even in this case also the numbering must be from bromine side, that is 1, 2, 3 and 4. So it is also following the least sum rule. Okay. So now what should be the name of such type of compound? It is 1-bromo, 2-chloro, 1-bromo, 2-chloro, butane, 1-bromo, 2-chloro, butane. Now I will take one more peculiar example in which you may get confused, that is CH3 CH Cl CH Br CH3. Now I have changed the position of halogen atoms. Now in two ways we can number. Okay, that is 1, 2, 3, 4, or else you can number 1, 2, 3 and 4. Now if you say in either left to right or right to left, the functional groups are falling under second position and third position. So here we are getting the same number. Here we are getting the same number if you sum up this 2 and 3, that is 2 plus 3 here also 5, 2 plus 3 here also 5. So that means least sum rule is not applicable here. Both are same numbers. But it's not like you can take any way. Why? Because if two different halogen atoms are present, then you should also consider alphabetical order while giving IUPAC nomenclature. That means bromo starts with the letter B, chloro starts with letter C. So which will come first in alphabetical order? B. That means bromine should fall under least number. That's why even though according to least sum rule you can give in either way numbers, but you have to follow this way of numbering, not this one, because you should also take care of alphabetical order. So I am crossing this one. This is wrong way. This is right way of numbering. Now here 2-bromo, the correct name of the compound is 2-bromo, 3-chloro, 2-bromo, 3-chloro, butane. Okay? It is not 2-chloro, 3-bromo. If you are saying it 2-chloro, 3-bromo, then that is wrong way of representation according to IUPAC. So it must be 2-bromo, 3-chloro, butane, because we are following alphabetical order. Okay? Now, some more examples, let us say, for IUPAC nomenclature. Now, if I have a compound like this, CH2, 3H2, CH2, CH, Cl. Okay. As you know, this is a cyclic compound. Okay, it is a cycloalkane. According to IUPAC, you should call this one as cycloalkane. Cycloalkanes. In this, how many carbons are there? 6 carbons. Means it is a cyclohexane ring. It is. Now, wherever the halogen atom is attached, from there the numbering starts. In this case, that means the number must be given to this carbon first. So it is 1-chloro, or you can say simply chloro also, because sometimes one need not be represented. So because it is only one functional group we have. 1-chlorocyclohexane. This compound is 1-chlorocyclohexane. If for example on the same compound we have 2 chlorine atoms, instead of 1 chlorine we have 2 chlorine atoms, then what should be the IUPAC name of this compound? Here on the first carbon we have 2 chlorine atoms attached. So if you have 2 functional groups di and the number should be repeated twice, so it must be, the name must be 1,1 dichlorocyclohexane. Okay. So if 1 chlorine is present, I am using only one time alpha, that is number 1 chloro. If 2 chlorines are present, it is 1,1 dichloro. So as you know, if 2 chlorine atoms are present on same carbon, it is one of the examples for gem-dihalo. Okay, gem-dihalide. It is an example of gem-dihalide. Okay. Similarly, if you take one more example of such kind, CH2, CHCl and Cl. If I have a compound of this kind, then what should be the IUPAC name of this compound? The IUPAC name of this compound, if I number from this side, so you look here, this will be 1, and if I go from this carbon in anti-clockwise direction, then it is 1, 2, 3, 4, 5 and 6. So here it will become 1 and 6. Okay, 1 and 6 positions, the carbons are counted. But if you take like this, 6 plus 1, it will be 7. It is a bigger number. But instead of going in anti-clockwise direction, if I go in a clockwise direction, if I do counting in a clockwise direction, then I will write like this now. Here 1, then here it is 2, 3, 4, 5 and so on. Now what is happening here? 1 plus 2 means now you are obeying least sum rule in this case. So what should be the actual name of, IUPAC name of this compound? 1, 2. It is 1, 2. 2 chlorines are there, so I am writing dichlorocyclohexane. Okay.